Okay, so we're going to solve problem homework 7 on trusses from 2021 spring. And I'm going to go ahead and solve this both ways by doing both sections and joints, although this one is definitely easier to do by sections, or at least quicker. Let's see. So the things we want BC, which is right here. We want BD, which is right here. And we want AC. And so that right there is why this is easier to do with the section, is because I can very easily cut these three things off and make this my free body diagram. The other thing that makes that really nice is that I don't have to worry about the external forces at C or G. I do not have to solve those first. When I do this using, joints, I'm going to need this and or that. I guess it depends on where I start, but I'm going to want them no matter what, because when you do joints, you always want to go all the way to the end. Okay, so you can check your work. So let's go ahead and do a free body diagram of our section. So we'll do this by sections here. Okay, so we'll go like, we are not going to go that far, are we? Right? We're only going to go a little bit down this way. Right, and we're going to draw this little, like that little symbol that says, hey, look, it keeps going. Right, and then we've got forces on here. I've got a 40 kilonewtons right here. I've got a 60 kilonewtons going right here. Okay, let's keep our forces in red. That will kind of make this stand out. Although up here it looks like I've switched the color switched from up here, but whatever. All right, so now we got like that, right? And so you can assume these things in any direction you want. I typically assume that my forces are compressive. I don't know why, that's just the way I do it. Okay, so this force is AC, this force right here is BC, and this force right here is BD. Okay, so this is statics. We always have three equations. In 2D, we always have three equations. Some forces in the X, some forces in the Y, some moments in the Z. Okay, so let's start here. Some of the forces in the X equals 0, some of the forces in the Y equals 0, and some of the moments in the Z around some point equals 0. All right, so in the X direction, let's see what we've got. Well, we've got unknown forces. We've got 1, 2, 3 unknown forces that have X components. Okay, we're not going to do the X equation first. That's a stupid equation. Okay, what about the Y direction? Well, I've only got this is the only unknown in the Y direction. So it seems like a pretty reasonable place to start. I think we'll start there. Okay, so let's see what we can get. We've got negative 40 kilonewtons on this thing. Let's zoom in a little bit. And we've got BC in the Y direction, right? So that means it's going to need a sine or a cosine there. So we need this angle, right? We need an angle here, probably be a good one, or here, or maybe here. Any one of these would be fine, right? So we need to figure out that angle. So let's see. So if I drop this vertical all the way down, it's going to hit right here. So this is going to be 3 meters. This vertical is 6 meters. So that angle is, let's call it theta. Theta equals the inverse tangent of the rise, 6 meters, over the run, 3 meters. Right? So what is that? 63.435 degrees. Okay, so if that's the case, then that means the vertical component of this force, which is kind of going like this, or I guess over here, it's kind of like this portion of it, not the horizontal portion, is going to be the sine of that angle, because it's the opposite, so it'll be sine of 63.435. Okay, I'm going to need a little bit more room than that. 60, come on, punk. 60, and you can hear my dog snorting in the background. 63.435 degrees equals 0. So we can solve this for BC. Okay, and we get, some number. Okay, the key here is we got a positive sign, so that means BC for reporting is 44.7 kilonewtons, and it's going to be compressive because we assumed compressive, and we got a positive number. Okay, cool. All right, so we got BC. Okay, box it off. Okay, now what about BD or AC? Well, in the X direction, we still have two unknowns, so I still don't really want to go back to that. So I'm going to do the sum of the moments in the Z direction, and I can pick really a few different spots. I recommend 2 spots for this one. I recommend spot C, which is out here, okay, because picking that spot means I don't have BC or AC, so I can solve for BD. I can solve for this one. It's the only unknown that doesn't go through that point. Or better yet, I can choose point B, because BC will go away, BD will go away, and this 60 will go away. So that's awfully nice, right? So let's go ahead and choose point B. Okay, so let's see. So we've got 40 kilonewtons. Okay, and it's its moment arm. So if we knock this thing back like that, its moment arm is about, looks like it's 3 meters. Okay, and that's going to cause things to want to spin in what direction? This direction. Right, so that's counterclockwise, so that'll be positive. And then there's AC, and its moment arm is from here to here, so that's 6 meters. Okay, and it's causing things to want to go, looks like it's causing things to want to go clockwise, so that's a minus equals 0. Okay, so I can solve this. It looks like AC is going to be 20 kilonewtons. We don't even need a calculator for that one. Okay. And again, let's see here. AC, let's see, 20, we could give 3 sig figs. And then we assume, we got a positive sign here, so we assume the correct direction. So this is compressive, which is pretty unusual, really. Usually the bottom is tensile and the top is compressive. However, in this case, we're outside of the restraint, the reaction force at the bottom. So what we can imagine is that this member right here, the 6 meters versus up here, is that this thing is trying to bend around that point C, and so the ones on top, well, it actually looks more like this, right? But that which is on top is lengthening. So this is getting longer, so and therefore it's in tension. Okay, and this is getting shorter, and so it's in compression. Okay, it's harder to see with this drawing, but anyway, that's the idea. Okay, so at that point, I can do sum of forces in the X if I want. Okay, and some of you may be more comfortable with that. So let's go ahead and just do that, because why not? So we've got a 60 kilonewtons in the plus. We've got minus BD. Okay, we've got BCX, so we've got minus BC, which is 44.7 kilonewtons. Okay, now we need the portion of that that's in the X. So we need, I'm going to go ahead and erase this side because we don't need any of this anymore. Come on, you can do it. Erase, you punk. All right, there you go. Get out of here. Get. Oh, I just lost that angle. Okay, hopefully, come on, give me the pencil, you punk. This isn't that long of a video, it shouldn't be freezing. Okay, 63.435. Okay, so this will be times the cosine, 63.435. We got a new blue color here, I hope you're excited. Okay, what else do we have in the X direction? Minus AC, so minus 20 newtons. Let's get rid of all of this nonsense. Well, that's an answer, so we'll leave that. Come on. It's really unbelievable. All right, 20 kilonewtons. Okay, and that's it, equals 0. Right? I think so. In the X direction, we got a 60, got it. We got a BD, got it. BC in the X direction, got that. AC in the X direction. Okay, and there's only one unknown, so we can solve that. So BD equals, okay, and it comes out to something like this. I will note I broke my own rule right here, and I like to keep at least 5 sig figs throughout the problem. Unfortunately, I erased the number that was right here, so I don't remember what that number was. In this case, I could tell that it was 20 so it came out as 20 kilonewtons, and it comes out to something like this, okay, and it was positive, so it's compressive. It's compressive on top and the bottom, which is rare. However, you'll note that there's this 60 kilonewtons that's pushing this way, And the tendency of that is going to be to compress this top. Okay, so that's where that comes from. Okay, so let's write these down somewhere so that we can check them later. Okay, so AC equals 20 kilonewtons in compression. BC equals 44.7 kilonewtons in compression. And BD equals 20 kilonewtons in compression. Okay, so we'll check those answers. And basically what I'm going to do is I'm going to take an eraser. We're going to keep that angle because that angle is going to come in handy. All right, and I'm just going to erase all this junk. And we're going to start over, right? But we're going to do this via our old friend joints. I love doing these by joints. I just think it's really a lot of fun. Okay, now I'm going to do this the way that I do this, not necessarily the best way to teach it, except that, you know, if you can get to this level of understanding, I think it will, you know, I think it will be beneficial to you. So let's kind of start rolling here. Come on, give me some love. Okay, come on. Hold on, optimizing memory usage. I don't know what the problem is. I need to figure out how to delete things off of this I thing. All right, so the first thing I'm going to do if I'm going to want to do joints is I could start at A and start working my way through, but I'd like to go ahead and get these reactions. So here's a C. Let's use black here. Let's erase that. Okay, so we're going to follow the, so here's my CX. Excuse me, CY. Well, there is no CX, so I'm just going to call that C. Okay, and then over here I'm going to have a GY and a GX, like this. Okay, so I need to get those before I start. I mean, I don't necessarily have to do them before, but it seems like it's just going to make the whole process a lot cleaner. Okay, so again, 2 dimensions. Okay, sum of the forces in the X equals 0. Let's see here. We've got 60 kilonewtons to the right, and I've got GX to the left. So GX equals negative 60 kilonewtons. Okay, so because I want this to be simple, I'm going to go over here and I'm going to erase this GX. And I'm going to put in, come on, you can do it. All right, here we go. 60 kilonewtons to the left. Okay? All right. Okay, let's see. Sum of the forces in the Y equals 0. Okay, this one's a little bit trickier, right? So let's see. We've got a negative 40 kilonewtons in the Y. We've got plus C. We've got minus 80 kilonewtons. We've got minus 100 kilonewtons. Plus G sub Y, okay? And all that adds up to 0. Okay, we can't solve that, but at least I can make it kind of prettier. C plus GY equals, let's see, 120, 220, 220 kilonewtons. Okay? All right, and then the big doozy and the one that really would have been better than that sum of the forces in the Y is the sum of the moments in the Z. And then the key always is where do we want to take it. And we want to take it wherever we can get rid of the most forces. So I'm going to take it at G. Okay. Yeah, because we not only get rid of the most forces, but we also get rid of one of our unknowns, which is GY, which I don't feel like dealing with GY. Okay. So we've got this 40 kilonewtons. Okay. And its distance is going to be 18 meters. Okay. And it looks like that's going to cause things to spin this way. Right, so that's counterclockwise, so I'll get a positive. So C is going to go the opposite way, and its distance is 12 meters. Okay, and then we've got 100 kilonewtons, which is the same way as that first one. Okay, but that's only 6 meters away. Okay, and then we need to deal with that 80. Let's see, which is also kind of downward plus 80 kilonewtons. And that one's distance is 6 plus half of 6, which is 9 meters. Okay, and then we got to deal with that 60. Okay, and that 60 kilonewtons has a distance of 6 meters away. Okay, and its direction is, it looks like it's going to be, that's like a clock, so that's negative. Okay. So let's solve this sucker. Okay, where's my calculator? C equals 140 kilonewtons. We like it when it comes out to nice, pretty numbers like that. Okay, so I can go over here to this one, and I can say, okay, well, if C is 140, then GY, if I plug that in algebraically, GY is 80 kilonewtons. Okay, now on this, all things rest, right? If I get these wrong, then everything's going to get all screwed up, right? So we didn't make sure that we get them right. At this point, we're going to hope, okay, because otherwise I have to remake this video. Probably in the morning. It's getting a little late, but I hope not, because I'd like to upload this tonight. 140 kilonewtons for C, and then for GY, we're going to get 80. Come on, you can erase. Right here. All right, 80. Come on, you can do it. Come on. 80 kilonewtons. All right, so I'm going to go ahead and erase these, because I don't really like these big lines. I mean, they can be useful, but I don't really want them there. Okay, I don't really want any of this stuff either. Okay, so, you know, it's a video, so you were able to copy down whatever you need. Unlike when I teach and I get, you know, if ever you guys become teachers, one of the biggest problems you have when you become a teacher is you want to erase everything, and I don't know why. But one thing to note, your students don't like that. Okay, so just be careful with that. Okay, so we've got the angle up there, 63.43 whatever. And we'll note that that angle applies here. Come on. Okay, it applies here and here and here and here and here and here, right? Okay, it does not apply right there. Okay, so don't get too excited. Okay, it also applies here and here and here and here, right? Just be aware of that. Okay, so let's start. Now, the nice thing about doing this by joints is that we do not need to worry about moments. Okay, so if you really hate moments and they just annoy you, well, then going by joints is the way to do it. Okay, so I'm going to zoom in on this sucker right here, and let's see what we've got. Okay, so let's see. This one, so this 40 kilonewton force, so I'm looking at A here. So I've got 40 kilonewtons going down. Okay, that means this, the only upward force on this thing is this one. So this one has to pull upwards, doesn't it? Okay. So the little force triangle here basically has to look like this. This, the Y component has to be 40 kilonewtons. Okay. Now I know this angle is, what, 63.435. Okay. So let's see, 63.435 degrees. Okay, so let's go ahead and get those sides, right? So we'll do a little trig over here off to the side here. So this is the opposite side. So the sine of 63.435 degrees equals the opposite, 40 kilonewtons, over the hypotenuse, right? So we'll do, so the hypotenuse then is 40 divided by the sine of 63.435, 44.721. 44 point, well, we know where we like to put that, right? We usually like to put that right out here. 44.721 kilonewtons. Okay, that's my, I guess I can put it on the little triangle too, 44.721, right? Okay, and then we need the x component, right? So basically I can just do 44.721 times the cosine of this angle. Okay, so I'll do times the cosine of 63.435, and we get 20.0 kilonewtons. Okay, which of course actually we knew all along, didn't we? Right, because this big triangle, this side is 6, this side is 3, so we knew that this side was twice as big as that side. So if this is a 40, this has to be a 20. Okay, anyway, okay, so let's erase this business. Okay, so we're pretty happy with that. So that means we know the, this is 44.721 kilonewtons, and it looks like it's pulling, so this is tensile. Okay, now note that this number we should be happy with, right, because we have one of these numbers over here, right, so we have to feel like maybe we're heading for something good here. Okay, anyway, so I haven't balanced A yet, right? because I still have, so in the vertical, I've got 40 kilonewtons up matching with 40 kilonewtons down, so we're good. In the horizontal, I've got 20 kilonewtons to the right, so I need 20 kilonewtons to the left. Okay, so this then looks like this, 20 kilonewtons. Okay, and it's pushing, so this is compressive. And I believe this was one of our questions, right? So this is AC, so if we go up here, come on, we'll see AC. Right, where are you, AC? 20 kilonewtons, okay, compressive. So I've got to feel pretty good about this so far, right? All right, so let's stare down here. I've got this one right here. This one's got too many forces, right? I've got 1, 2, 3 unknown forces. Let's not do that one. Okay, let's go to this one. Okay. So I'm going to take this thing right here, and I'm going to convert it using this triangle. So basically it's the same triangle. It just looks like this, right? So this is 40 kilonewtons, and this is 20 kilonewtons. Okay, so let's see what we've got here. Okay, so we've got both this one and this one have components in the y direction, but only this one has components in the x direction. So let's balance the x first. Okay, so if we're balancing the x there, I've got 20 to the right here. Come on, give me some love. Come on, man. All right, so we got 20 to the right here. And I've got 60 to the left right here. Oh, it's hard. They both have components in the x. I need to get the y first. Okay, so in the y, I've got 40 kilonewtons going down. So I'm going to need 40 kilonewtons coming up, right? Because that's the only other place I can have it, right? So this thing then looks like this. So this is going to be 20 kilonewtons here. This is a 40 kilonewtons up. Okay, so this whole thing is going this way, right? I have a value of 44.721 kilonewtons. Okay, so now we summed in the y, right? Now what about in the x? Okay, well, we've got 20 to the right, to the left. We've got 20 to the left. We've got 60 to the right. So means we need 20 more to the left to balance this whole thing out. Okay, so this becomes 20 kilonewtons. Okay. And so now note this 44.721 kilonewtons. Same force triangle. Okay, 40 kilonewtons, 20 kilonewtons. Okay, beautiful when it just kind of keeps on working that way, right? Now this 20 over here, it's pushing on both things, so this is compressive. This 44.721 kilonewtons, it's pushing in both directions, so this is also compressive. Okay, so BC is 44.721 compressive, right? And BD is 20 kilonewtons compressive. Okay, so we're good there. All right, so now we're cooking with gas. If we go up to this top one, I've got 1, 2, 3 unknowns, so let's not do that one. Let's go down here. I've got 2 unknowns, it looks like, because since the last time I looked here, that one went away as an unknown. So let's see, I've got, well, what is this force? 140. Okay, so in the vertical, right, in the horizontal, both of these have horizontal components. Both the unknowns have horizontal components, so I don't want to do that. All right, so let's do, come on, punk. I really hate switching. Okay, here we go. So in the vertical, I've got 40 going down right here. I've got 140 coming up right here. So that leaves kind of a, we need 100 coming down right here. 100 kilonewtons coming down. Okay, and we'll have to solve for that triangle. Although I can tell you right now, before we even solve it, that this is going to be 50 kilonewtons, right? Yeah, right, because the vertical, because this side is always going to be 2 times that side, right? Because they're similar triangles. Okay, but let's go ahead and do the trig, just because some of you guys are happier with sines and cosines, which just shows kind of a how we've messed up as educators, because it should be much easier to solve similar triangles than to do sines and cosines, although they are all the same thing. So 63.435? Yeah, we're going to go with that. 63.435. Okay, so degrees. Okay, so we've got the vertical. We need to get the hypotenuse. So let's see, this is the sine of 63.4335 degrees equals the opposite, 100 kilonewtons divided by the hypotenuse. Hypotenuse equals 100, 100 divided by the sine of 63.435 equals 111.80. I hope I got that angle right. I guess we can find out in a second, because I'm going to take that number and I'll multiply times the cosine of 63.435 to get the adjacent side. What? No, right. Times the answer. Sorry. Yeah, equals 50. So this is 50 kilonewtons. Okay, so there it is. All right, that's our little force triangle. So now we know that this side right here is 111.80. Okay? Sweet. Oh, that's not in degrees. All right, and if we notice which way it's pointing, come on. I wonder if it's recording during these moments when it's frozen. I wonder if you can hear my voice. I should say, something funny. I should leave a funny joke and probably just can't hear the punchline or something. All right, so anyway, so there we go. Okay, so in the verticals, we now add up, right? We've got 140 right here, and we've got 40 and 100 right there. Okay, in the horizontals, let's see, we've got 20 to the right, 20 to the right, 50 to the left. Okay, so that means we need 10 more to the left. Come on, you can erase. I know it bothers you. Okay, so we've got 10. This drives me nuts. I shouldn't erase anything else. Okay, I'm going to try to avoid erasing so that we can avoid these freezes. Optimizing memory usage. I need to learn how to delete stuff. Okay, so let's go. We need 10 more to the right. So it's going to be 10 kilonewtons to the right. Okay, so it's going to look like that. Okay, so this one, let's see. This one is pushing on both sides at 111.80. So because it is pushing, this is compressive, kilonewtons of compression. Okay, this is 10 kilonewtons, and it is tensile. We haven't had a lot that was in tension on this thing, have we? It happens. Okay, and then, so once again, if we go down here, we don't know what these are because there's 3 unknowns. So let's go to this one, where we know most of the stuff, right? So this one is 50 and 100. Right, so we can go up to this guy right here. Okay, and again, the easiest thing here is the vertical because there's only one unknown in the vertical. And so we've got 100 going up right here, and we've got 80 going down. So that means we need 20 more going down, 20 going down right here. And by similar triangles, that means this is going to be a 10. And by similar triangles, this whole thing is going to be half of this 40/20, so it can be 44.721 divided by 2, so it's going to be 22.360 kilonewtons. Okay, so there you go. I'm not working that triangle. What's important to see is that we needed this 20 down because we had 100 up, and we had 80 down, so I needed another 20 down. Okay, so that gives me 10 to the right, 50 to the right, so it's 60 to the right. This is another 20 to the right. Whew. All right, so now we've got a grand total of 80 has to be pushing back right here. So this is 80 kilonewtons, and that's compressive because it's pushing on the joints around it. Okay. All right, so let's go on down here. So this thing now is going to be like this. Okay, and it's 22.360 kilonewtons, and because it's pulling, it's tensile. Okay, and it's going to be 10 in this direction and 20 in that direction. Okay, so let's look at this sucker. And let's see, again, the vertical is easier because I only have one vertical force that's unknown, right? So I've got 20 going up, and I've got 100 going down, which means I need an additional 80 going up to support that joint. So this is 80, right? And by similar triangles, I know that this is going to be 40. Okay, and this number is going to be double that 44. So it's going to be 89, excuse moi. Yeah, that's French for excuse me. 89 point, what's that, 442 kilonewtons, right, in this direction. Okay, and that's pulling, so that's tensile. Okay, so I can go ahead and put that here if I wanted to. 89.442 kilonewtons. Right, and here we go. It looks like that. So 40 and 80. Okay, so that's going to be helpful. All right, so now we're going to go down here. Let's do the x direction. So sum of the forces in the x have to be equal to 0. So I've got 10 to the right here. I've got, 10 to the left right here, 10 to the left right here, 40 to the right. So that means I need this one to give me 20 to the right, to the left, right? In order for this all to add up properly. Okay, so we get 20 right there. Okay, so this is compressive. Okay. So now we're going to go up to this one right here, and we're going to hope that this all works out for us. We have no idea, really, right? I have a bad feeling about it, but it looks pretty good, I think. Okay, so we can do the x or the y here, because I only have one unknown. We'll note that the x direction, I've got 40 to the right, to the left, and I've got 80 to the right, which means I need another 40 going this way. Right? Let's see if that also works with the y direction. So in the y direction, I've got 80 coming down, so I'm going to need 80 going up. So this does work, right? Okay, which means that I get this, this force going like this, which is 88.442 kilonewtons. Okay, and based on its directionality, it looks like it's pushing, so this one's in compression. Okay, so this one right here is going like this, and it's 88.442 kilonewtons compression. And again, same force triangle, 80 and 40. Okay, so let's see if this all adds up. So in the x direction, we've got 20 to the right, 40 to the right. That adds up to the 60 to the left. We're looking good. In the y direction, we've got 80 down, we've got 80 up. Boom. Okay. QED. We like QED. Okay. The only last thing that I would suggest that you do at this point is you go in and you round all of these to 3 sig figs. I'm not going to bother with that at this point, but this is this is how I solve these things, and this is how, I don't know, if you can get to where you can see it this way, I think it can be very helpful. So anyway, hope you're having a good night, and take it easy. So take care of yourselves. All right. Goodbye.